Okay, so let's look at the Piecewise Functions notes handout that I gave out in class on, I don't know, Wednesday for most of you. Um, so I'm just going to run through the lesson again for those of you that want to review it or were absent. So in the handout, we started with a basic function, y equals x squared. And so I've already graphed it here, and I purposely went by twos just because later on that'll come in handy as we work our way down. So I already made the table. X squared is pretty easy to graph. So I made the table. I already graphed the parabola right over here on the right. So then let's kind of review what's domain. And if you remember, domain refers to all the x values that you're allowed to plug in. And if you look at y equals x squared, well, there's no real restrictions on what x can be. So the domain is everything. So from negative infinity all the way up to positive infinity. So I'm going to say x has to be between those two values. Or if you wrote it using interval notation, you could say or the interval. And then from negative infinity up to positive infinity. And I would use parentheses around them because technically you can't actually make it all the way to infinity, so you don't include them. The range is all the y values that you can get. And this one, I think it's useful to look at the picture. If you actually look at the picture, the smallest y value you can ever get is 0 right there. And you can actually get 0. So I'm going to do less than or equal to there. So 0 is less than or equal to y. And then the biggest y values you get, it just keeps going up. So I can get any y value I want, so up to infinity. So if I wanted to write this in interval notation, I'd say the interval from 0 to infinity. The infinity I can't include, but the 0, it's actually could equal 0, so I use that square bracket instead. So that's how we write those. And in number 3, I'm graphing the same thing again, but now I'm putting a restriction on my x values from -2 to 4, where we include the -2 but not the 4. So I've already kind of put little axes on, little tick marks on my axes. And what I'm going to do is I only care about the graph if the x values are between -2 and 4. So what I'm going to do is I'm going to draw a couple dotted lines here at -2 and then again at 4. And this region right here is going to look just like y equals x squared. But it's not going to exist out here, and it's not going to exist out here because I don't have any graph for that. I only care about between -2 and 4 for my x values. And in fact, what I'm going to do is I'm going to say, well, now this is just my own notation to help me remember stuff, but I want to include the -2 side in my graph, and I want to go up to but not include the 4 on the other side. So that's kind of why I'm using the bracket on one and the parentheses on the other. But again, that's just my own made-up notation. So it's really just like the parabola that we graphed up here, except that if I only care about from -2 up to 4, I'm going to get rid of this region here and this region over there. So now the picture looks like, now I still have the same chart essentially. So it goes through 2, 4 right there, -2, 4, 0, 0, 2, 4, and 4, 16. But then you need to include one part and not the other part. I want to include when x equals -2. So for that one, I'm using a full solid dot right there. But on the other side, I go up to but not including 4. So the y value goes up to but not including 16. And the way that I denote that I don't actually include that one is I make it an open dot there instead. So my graph looks like a parabola, a piece of a parabola, but not a whole parabola there. So it looks like this with an open dot. And so typically what you do is you label some of the important points on this piece of the graph. So the, 416 is an important point because it's an endpoint. And I'm just going to write next to it, note that it's an open dot. 0, 0 is important because that's the vertex. And then over here, we've got x is -2, y is 4. That's also one of my endpoints, but that one's a closed dot because x was allowed to be -2. Okay, so really there's my picture right there. It's that chunk of a parabola, just a piece of the parabola. Okay, so let's go on to the bottom here. And in class, I actually changed these 3's to 8's. So we'll make that an 8, and we'll make this one an 8, just because it ends up making the picture a little easier to draw. Otherwise, stuff kind of gets in the way. So in this one, we're graphing a two-part function. One part is the part that we've already done. So let me draw my tick marks on here. Here's -2, here's -4, here's 2, here's 4, and then we'll go by 4s on this axis. So 4, 8, 12, 16. And so for this one, let's see. I'm gonna have a chunk, a piece of my graph for all the x values that are less than 2. So, sorry, less than -2. So I'm gonna have a region of my graph that's over on this side here, on this region over here, something over here. And then I'm gonna have another chunk of my graph that goes from -2 up to 4. And the part between -2 and 4 is at y equals x squared. So in the middle here, my graph should look like y equals x squared. And again, up to 4, but not including it. And on the other side, all the way down to -2 and including that one. And then for everything less than x equals -2, my graph should look like y equals 8 right there. So on this side of the graph, it should look like y equals 8. And so what I'm going to do is I'm going to put up parentheses here because I go up to -2, but I don't actually include the -2, and then all the way down to -infinity. So really, this is kind of the key to, well, what do I graph here? Well, the middle chunk, right, in this region here, well, that's the same thing as what I had before up here. So I can just redraw that same stuff. 0, 0, this one's a closed dot. This one's 2, 4, and then up at 4, 16, I've got my open dot. And so here's that parabola again, or that piece of the parabola. And then I've got this other region on the left side here, where y is supposed to be 8. And y equals 8 normally looks like a line right through, a horizontal line right through 8. Well, this one, I have y equals 8, but only when x is less than -2. So I would draw the y equals 8 line, but I'd stop it once I get to x equals -2, because at that point, the parabola part takes over. Whoop, sorry, deleted that by accident. So there's my line. And then I go up to x equals -2, but I don't include it. So I'm going to use an open dot right there. And then just to kind of, we want to label some important points. Oh, and I can keep going this direction too. So if I label some important points on here, well, this endpoint right there is -2, 8, and that one's open. This one right here is -2, 4. My important vertex is 0, 0. This one is 4, 16, and that one's open. This one down here is closed. So then let's ask these questions, even though it's not listed here. What's the domain and what's the range? Okay, so the domain are all the x values that I'm allowed to plug in. Well, if I said, can you plug in -100, you can. And this is the blueprint that tells you what to plug it into. If x is -100, well, then I'm in this part of my graph. -100 is less than -2. I'm not in this part. So I can plug in fact, I can plug in any x less than -2. So I can definitely plug in from -infinity up to at least -2. And then the question is, what can I plug in -2 for x? And the answer is yes, because if I have -2, I just plug it into the bottom equation instead. So I can actually include -2, and I can include everything from -2 all the way up to 4. So I actually am going all the way up to 4 at this point. And then nothing past 4, because there's no blueprint for that. There's nothing that tells me, well, y equals this if you're bigger than 4. So it's up to, but not including 4. So in interval notation, you could write it like this. So then the y values for the range, that's more useful, I think, to look at the picture. And if you look at the y values, the very lowest one I can get is 0. And that's at the vertex down here. And then if you look at all the other y values that you can possibly get, well, I get every y value I could want between 0 all the way up to 16, but not including it. So, and then I have no y values that are higher than 16. So I can say up to, but not including 16, and in interval notation, that'd be bracket 0, comma 16 parentheses, because the 16 is not included, but the 0 is. Okay, and so the reason it's called a piecewise function is because it's really a function that's defined in separate pieces. In this case, there are two pieces. The y equals 3 for everything that's to the left of negative 2, and y equals x squared for everything in that middle region right there. Okay, so let's take a look at the next page here, and we'll do that one example, which is what we did in class. So in this one, it's got 3 chunks to it. So the chunks are defined right here. They tell you what your kind of mini domains are for each piece. So for one of the pieces, it's everything less than -1 or equal to -1. So right here at -1, I'm going to draw a dotted line going all the way up and all the way down. And I'm going to say over on this side of the graph, I want my picture to look like y equals -3x plus 1. And it goes up to and including the -1, the x equals -1, and all the way down to negative infinity. So that region right there is going to look like y equals -3x plus 1. The middle region goes from -1 to 3. So I'm going to draw another line here at 3. And that one, it should look like y equals x in the middle, because that's what my blueprint says. The f of x is just x for that middle region. So when I do that one, I don't include the -1 and 3, so I'm going to put parentheses on the ends there. And then the last part is, well, y is just -2 for everything bigger than x equals 3. So everything over here, x is bigger than 3. And I'm going to say it should look like y equals -2 on that piece. And this one, I'm going all the way down to and including 3, and then all the way up to infinity. So right now I've got kind of the setup for what my graph should look like. So I'll tell you a common mistake students make is they say, well, okay, I got to graph this line. So I'm going to start at the y-intercept of 1, and then I'm going to use the slope of -3, so go down 3 over 1, and then they draw this. Well, the problem with that is you're drawing that line in the wrong chunk, in the wrong region right here. So that's not actually accurate. Oh, sorry, not -1, +1. So really it would look like this, down 3 over 1. So it would look like this. But then you're drawing the whole line, and you don't want the whole line. You just want the part that's over here. And since it's a line, you really only need a couple points. So what I would do is I'd just make a mini chart right here, x, y equals -3x plus 1. And include the endpoint. You know, you need to plug in -1 because we want to know where the y value is so that we know where it ends. So if I plug in -1 into this, I get 4 for my y value. So I know it goes through -1, 4 right there. And notice I'm using a solid dot because I'm actually including that part of the graph. And then I want to work my way backwards instead of forwards because I don't want to go into this region over here. So if I plugged in like -2 or -3, this one's going to be 7, this one will be 10. So then if I plot those points, -2 up to 7, -3 up to 10 way up here, here's that part of the graph right there. There's that region. Okay, so let's do the middle chunk, y equals x. So y equals x, if we made a little mini chart for that, x, y. Well, the easiest points to plug in here would be like, well, let's pick the endpoints. So -1 up to 3. So -1, well, y is the same thing. 0, 0, 1, 1, 2, 2, 3, 3. But notice I'm not actually supposed to include those endpoints. There's no equals there. So this point and this point aren't actually going to be included on my picture. So when I draw -1, -1, I'm going to use an open dot. And then I can work my way up with a slope of 1 to 3, 3 right here, which is also an open dot. Okay, so now at this point, I've got the 2 chunks. I've got a third chunk left right here at y equals -2. That just means everything looks like -2. So that would be this line right here. And I want to include the endpoint on that. So I'm going to draw a big dotted, solid dot right there. And this point would be 3, -2. So there's my function. That's the full graph of the whole thing. And if I said something like, what's the domain of this thing? Or no, actually, let me skip that for now. If I said, what's f of, I don't know, let's say 5, right? That means what's the value of the whole function when x is 5? Well, you can do that from the picture, but you can also do it from here. X equals 5, right? So then come over to your blueprint part and say, well, which part should I use? Well, 5 is bigger than 3, so I'm going to be using this graph right here. Y is -2, so f of 5 is always going to be -2. If I said, what's f of like -4, let's say, well, then my x is -4. That means I got to use this top one. So I plug it into this thing. So f of -4 is going to be -3 times -4 plus 1, which is going to be 12 plus 1, 13. Okay? So I'm going to stop there. That's about as far as we got in class. Hopefully that helps a little bit. And I'll see you guys next class.